Okay, class, in this lesson, you are going to learn to solve quadratic equations using the quadratic formula. Okay, so let's go ahead and get started with what the quadratic formula looks like. The formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. All right, I'm not going to spend any time explaining how this formula is derived, but what you will notice is that this is a very powerful tool in solving quadratic equations. So let's go ahead and get started with the first example. So here we have the quadratic equation 3x squared minus 4x minus 9 is equal to 0. And as you will quickly see, using factoring will not help you to solve this quadratic equation. And so when all other techniques fail, the quadratic formula comes in handy and will help you to solve all quadratic equations. So let's go ahead and remind ourselves what the quadratic equation is. And I'm going to place it over here. So in the equation, we see that we have the letters B, A, and C. So we're going to go ahead and identify what those are first. Let me just go ahead and move this over a little bit. Okay, so the letter A refers to this coefficient 3. Sorry, not 3. A. And the number negative 4, I'm going to go ahead and notate that as our coefficient B, and then the last, negative 9, is our coefficient C. Okay, so now that we've identified A, B, and C, we can go ahead and just insert those numbers into the equation. So we have the following: x is equal to negative, and B is negative 4, so we're going to write negative 4 in here, and that's plus or minus the square root of B squared, which is negative 4 squared, minus 4 times A, which is 3 in this case, and then times C, which is negative 9. Okay, and that's all divided by 2 times A, which is 3 in this case. Okay, so we're going to go ahead and continue to simplify. Negative 4 would just be a positive 4. And that's going to be plus or minus the square root of, and this is going to be 16. We have two negatives here. We have a negative here and a negative here, so we're going to end up with a positive here. And so that's going to be 12 times 9, and that's all divided by 6. Okay. Further simplifying this, we get x is equal to 4 plus or minus the square root of 16 plus 108. And that's all divided by 6. Okay, and then continuing to simplify this, this is going to be 4 plus or minus the square root of 124. And that's going to be all over 6. Okay, and then the last part here is to find factors of 124 that can be taken out of the square root sign. Okay, so we can go ahead and break that up into 4 times 31. So that becomes x is equal to 4 plus or minus the square root of 4 times 31. Okay, and that's all over 6. And x is now equal to 4 plus or minus the square root of 2 square root of 31, all divided by 6. Okay, and now we can go ahead and simplify 4 and 2 versus the 6 in the denominator. And that comes out to x is equal to, we can factor out a 2 from all three of those numbers, so it's going to be 2 plus or minus the square root of 31 divided by 3. Okay, so that is essentially our answer. Or we can write it as x is equal to 2 plus square root of 31 divided by 3, or x is equal to 2 minus the square root of 31 divided by 3. Okay, so that essentially is our solution. Those are the different x values that make the original quadratic equation valid. Okay, so hopefully that made sense. As you can see, quadratic equation is very powerful. However, note that it took several steps to really get to the answer. And as you know from what I've stated in class before, when you have this many steps and so many computations, this opens up for potential errors, especially in your calculation. So while this tool, or while this formula is very powerful, you need to be very careful in each step of the way. And so you're going to want to move very slowly and make sure that each step is done correctly. Okay, because the slightest error will definitely throw off your answer. So that's one drawback to using the quadratic formula. And then the other drawback, as I mentioned before, is how many steps it takes to get to the answer. Okay, all right, so let's go ahead and move on to the next example. So here we have a way to identify how many solutions are available in a particular quadratic equation. Okay, so here we're going to identify the number of real number solutions. Okay, so this does not include imaginary numbers. And so within the real number world, we're going to identify how many real number solutions there are. And the way to do that is to use the radicand of the quadratic formula. In other words, the discriminant, or b squared minus 4ac of the equation. Okay, so let's go back to the equation. This part, okay, the value inside this radical sign is called the radicand, and this radicand happens to be discriminant. Okay, and the discriminant represents b squared minus 4ac. So if you use that expression, okay, and plug in the b and the a and the c into the discriminant, if that value is greater than 0, then that tells us that the quadratic equation has 2 real roots, or 2 real answers. If, however, the discriminant ends up being equal to 0, then the quadratic equation only has one answer, or one real root. Okay, and then lastly, if the discriminant is greater than, I'm sorry, not greater than, that should have been less than. Let me go ahead and correct that. If it is less than 0, then the quadratic equation has 2 non-real roots. Okay, so this is where the imaginary numbers come in. So again, greater than 0, we have 2 real roots. Equal to 0, we have 1 real root. Less than 0, then it has no real roots, which means it has 2 non-real roots. Okay, so let's go ahead and apply this in a couple of different ways. First, with the next example. So here we're going to interpret the discriminant. So in this problem, we have Rachel is about to serve and tosses a tennis ball straight up into the air. The height h of the ball in meters at time t in seconds is given by h of t is equal to negative 5t, and that should be squared, plus 5t plus 2. And the question is, will the ball reach a height of 4 meters? Okay, will the ball reach a height of 4 meters? I'm going to go ahead and correct that. Okay. So to determine that, we're going to use the discriminant to figure out how many answers there are in this particular quadratic equation. Okay, But before we do that, we need to kind of adjust the equation. So we have negative 5t squared plus 5t plus 2. And we're saying that we're going to determine if it reaches a height of 4 meters. So that's going to equal 4. Okay, now we're going to move this 4 over to the other side by subtracting 4 from both sides. And when we do, we get negative 5t squared plus 5t minus 2 is equal to 0. Okay, so now that we have the quadratic equation set up correctly, where we have the a and the b and the c equal to 0, we're going to go ahead and label this. This is my a, this is my b, and this is my c. And we're going to use the discriminant, which is b squared minus 4ac. Okay, and let's see what value we get from that. So that's going to be negative 5 squared minus, I'm sorry, not negative 5, it's positive 5. My b is positive 5, my a is negative 5. So this is going to be negative 4, or minus 4 times negative 5 times negative 2. Okay, and that works out to 25, and minus negative 5 times 2, negative 5 times negative 2 is positive 10. Positive 10 times 4 is going to be 40. Okay, and that works out to be negative 15. Okay, so because b squared minus 4ac is less than 0, then that means we have two non-real roots. Okay, meaning it's going to be an imaginary number. So then the answer is the ball will not reach a height of 4 meters. Okay, the ball will not reach a height of 4 meters. Okay, so we used a discriminant to help us to determine what type of answers there can be in this quadratic equation, and we see that these are non-real root answers, and so therefore the ball will not reach a height of 4 meters. Okay, and let's take a look at the next example about how the discriminant can also be used. Okay, so we're going to use the discriminant to find a particular equation. Okay, and here's the question. What value or values of b will cause the quadratic 2x squared, that should have been squared, plus bx plus 18 equal to 0 to have only one real solution? Okay, what does b need to be, okay, for this to have only one real solution? Well, let's use the discriminant. The discriminant here again is b squared minus 4ac, and it's going to equal 0 because when it equals 0 it only has one real solution. Okay, so then we can go ahead and plug in the values for a and c. We know that this is a, we know this is c, so when we go ahead and plug that in, we're going to get b squared minus 4 times 2 times 18, and that's going to be equal to 0. Okay, b squared is now going to be b squared minus 8 times 18 is going to equal 0. B squared minus 144 is going to equal 0. We're going to need to add 144 to both sides. And when we do, we're left with b squared is equal to 144. Okay, now we're going to square root both sides, and when we do, we find that b is going to equal plus or minus 12. Okay, so the answer is b needs to be either positive 12 or negative 12 that will cause this quadratic equation to have only one real solution. Okay, so this is our answer. Okay, we cover a lot of ground. We learned about the quadratic equation, how to apply it, and then we learned two different ways of using the discriminant to help answer a couple of these questions. Hopefully this made sense to you. If any of this was not clear, please go back to the beginning of this recording and listen to it again. Thank you.